right, so in this next little section here, they start talking about the multiplicity of a zero, and that is a definition that we need to know. It's a very standard definition that says that the multiplicity of the zero will be the degree of the factor from which it comes. So remember, the degree is the power, the highest power of the polynomial, and here we're talking about the degree of that factor. So if you look at a question like number 47 here, okay, you have f of x is equal to 4 times x minus 5 times x minus 3 to the third power. Now, it first asks us to find the zeros. So remember, to find the zeros, we just set the function equal to 0. So we set whatever our little function is equal to 0, and then we factor, and then we set each of those factors equal to 0. So if you look at the presentation of question number 47, the first thing that should stand out to you is when you set this equal to 0, your next step is I got to solve it, but you notice that this guy is already factored. And you know it's already factored again because you have parentheses, parentheses. So that is a very reason for celebration. We don't have to deal with this factoring mess. We can just set those parentheses quantities equal to 0. So what we do is we take our 4 is equal to 0, x minus 5 equal to 0, and x minus 3 equal to 0. And keep in mind, we talked about this in the last question, but you don't have to worry about this cube thing because it's really just going to be whatever is in parentheses. But you can write it down just for reference. You know that this is x minus 5, you're setting that equal to 0. This is x minus 3 to the third, you're setting that equal to 0. But really at the end of the day, it's going to be whatever's inside of that parenthesis. Now, before you can find the multiplicity, you have to find the zeros. So if you look at 4 is equal to 0, there's no x to solve for there. So that tells you that there's nothing to worry about as far as that becoming a 0. The x minus 5 is going to give us x is equal to 5. That is going to be a 0 of our function. And the x minus 3 gives us x is equal to 3. That again is a 0 of our function. Now, the new thing about this is now we have to find the multiplicity. So we usually denote the multiplicity with m, and that is going to be the degree, so the power, from which that 0 comes from. So if you look at the x is equal to 5, 0, and you trace it back to the parenthesis quantity, the factor that it came from, the degree, the power on that factor was 1. So that tells us that our multiplicity is 1. Now, if you look at the x is equal to 3, 0, if you trace that back to the parenthesis, the factor that it came from, you see that that degree is 3. So we would say its multiplicity is 3. Now, the next part of this is what we use the multiplicity for. So the multiplicity, if it is odd, so in this case we have an odd multiplicity, there will be a sign change. And so that means that our graph will cross at the x-axis. Okay, so again, if you think about it, you have a negative to an odd power, you're going to have to get a negative, and then if you have a positive to an odd power, you're going to have to get a positive. So there's going to be a change across the x-axis from that negative to the positive. So when it is odd, it will cross at the x-axis, and so over here, because the multiplicity is odd, it will also cross at the x-axis. So in this question, our zeros are 5 and 3. Multiplicity is 1 and 3 respectively. And because both of those multiplicities are odd, this function we will see crossing at the x-axis at those zeros. So it's going to cross at the x-axis at x is equal to 5 and x is equal to 3.